Cave systems are part of a specific aspect of geology called karst. The word karst is a Croatian word, I think. It's actually krst. There's no vowel in it at all, just K-R-S-T. But they've added an A to make it pronounceable. And that part of Europe is one place in the world that's characterized by this particular type of landform. It's actually rather different from what you see in southern Ohio and in Kentucky and in this part of the world. Here the caves are developed in flat-lying limestone layers. In that part of Europe, the rocks have been deformed and a lot of the layers are standing on end, so you get some pretty spectacular and different looking stuff there. But the simplest case to understand is actually what we have around here, so that's nice. The key to developing karst is that you have the right material. You need a material that will dissolve. There are a handful of materials that meet that criteria. Salt is one. Gypsum is another. Gypsum is a calcium sulfate mineral. But developing karst, and that's pretty rare because those are so soluble. Limestone works because, for a couple reasons. One is it fractures easily, and when it fractures, it tends to fracture at high angles relative to the layering planes. So we've got a block of limestone here. We've got what's called the bedding surface of the original layer surfaces across here, and then it's fractured at these high angles cutting across it. Well, those fractures become conduits for water. The more fractures you have, and the more you have intersecting planes here, the more water can move through there, and the more work can be done. Now, not all limestone is going to be equally soluble. Limestone is, in short, it's almost entirely a mineral called calcite, which is calcium carbonate. In long, there's no such thing as a pure geological material, and limestones and calcites will have varying amounts of magnesium. The more magnesium you have, the harder it is to dissolve the limestone. So you'll have alternating layers here, and some will be very easily dissolved, and others will be more resistant. You've still got the fractures, though, so that water can move between the layers and do its work. The other thing is that you need an acid to dissolve calcite, to dissolve limestone. And if you take a chunk and throw it in a bucket of hydrochloric acid, it's going to fizz like crazy and it's going to be gone in a matter of minutes. We generally don't have concentrated hydrochloric acid falling from the sky, although, thanks to pollution, we have sulfuric acid falling from the sky. But even before pollution, this process was going on because there's a natural acid that forms in rain, and that's carbonic acid. Now, carbonic acid is one that you're pretty familiar with. It's what makes soda fizzy. And before you panic, the phosphoric acid in cola is a lot worse than the carbonic acid, so the safest thing to do is drink beer. Now, carbonic acid there is formed by the reaction between water and carbon dioxide as it's falling through the atmosphere. Once it hits the ground and it percolates through the soil, it can pick up some more carbon dioxide there. So you get a carbonic acid solution. Now, we talk about strong acids and weak acids, and carbonic acid is considered a weak acid because it only undergoes a partial dissociation. You've got two hydrogens here, but only one of them comes off. So you've got hydrogen ion and you've got bicarbonate ion. The bicarbonate acts as a buffer, and if you have that, well, let's go on to the next line. So we bring our carbonic acid in contact with limestone. So we've got our calcium carbonate here. Partial dissociation, so we've got these free hydrogens in the solution. And what happens there is that the free hydrogens react with the calcium carbonate to form more bicarbonate ion and calcium ion in solution. This is energetically favorable for the reaction to go this way. But you look at that, and you might think, that's kind of tenuous. That equilibrium could shift the other way, and in fact it does. and we'll get to that in just a moment. Have you guys been in any caves yet in this course? You've been in caves before, though.
Yeah.
Good. Been to Carter Caves? Mammoth Cave?
Yes.
Carlsbad? Anybody been to Carlsbad?
Perry's
Carlsbad's weird.
Been to Perry's Cave.
Perry's up on
Put-in Bay.
Put-in Bay, yeah.
Yeah.
Those, the passages that you go through with those are notably dry. And the key to getting caves to form is that they not only have to be wet, they have to be flooded. These passages have to be flooded. And so you figure, well, then they must get drained out at some point. Yes, that's true. Groundwater. Water will fill all voids in the subsurface. If you have water present, it will fill those voids up to a point. Just like water will fill your bathtub up to a point when you run out of water. The top of this saturated zone is called the water table. And the water table, that's the level at which the caves are forming, because that's where you've got water moving through. It's in contact with the rock for long periods of time, so you get these dissolution reactions to go. The level of the water table in a cave-forming area is going to be controlled by the presence of a local stream. Okay? For Carter, that stream is, well, depending on which part of the park you're in, it's either Cave Branch or Tiger Creek. For Mammoth, it's the Green River. For the caves on Put-in Bay, it's actually Lake Erie. The stream there, though, it has an important part in all this as a surface body. Streams erode their channels. They make them deeper, and so that stream valley is going to be incised, and it's going to lower the water table, and these upper levels will become abandoned. Lower levels down here, still flooded, still active. So if you go to Carter, you go to X Cave in Carter. X Cave is the high-level abandoned passage. Directly below that, though, you have Cave Branch that actually comes in one side of the hillside and goes out the other side. That's the active level. Now, the deeper that stream goes, potentially, the more levels the cave can develop. Mammoth is, I believe, developed on, if I'm remembering right, the 6th level is active right now. I just had some students in the field methods class down at Carter before spring break, and they documented that the Cave Branch system in there, anyway, is developed on 2 levels. Ultimately, the surface erodes, and you may have collapse features, sinkholes. You may have lots and lots of sinkholes. That's actually pretty normal. You've still got this point out here where the cave system was originally discharging to the valley, and you can get into caves through here. You may have that on both sides. All depends on what your limestone, or on what your bedrock is, and how soluble it is. Let's take a nice example here. Is Mammoth Cave. Mammoth is very well studied and well described. It's easily accessible. It's about 4 hours from here, so if you have to kill a Saturday, that's a really cool place to do it. You'd be kind of tired at the end because it's 4 hours down. You probably want to do 4 hours underground and a few hours on the surface and then 4 hours back. You might want to stay in a hotel. The Days Inn is exquisite. What do you have at Mammoth? As I said before, you've got the Green River at the north end of the system. And you've got limestone underlying all this. And on top of that limestone, you've actually got a caprock of sandstone. To the south, you've got a sinkhole plain where that sandstone is absent. So when it rains, the water enters the sinkholes, and because these rocks are sloped slightly to the north, just dipping a couple degrees, the water flows up this way. Main discharge points are at a place called River Styx and at Echo River. These are 2 of the big discharge points where the cave system, the lowest level, is discharging directly out to the Green River. Now, you go up the valley wall, up the hill here, and you've got what's called the historic entrance to Mammoth Cave. It's right there by the Visitor Center. And the legend is that there was a hunter that he shot a bear, but he didn't kill it. He chased the bear, and the bear went into the cave, and he discovered Mammoth Cave. And they never say if he ever got the bear. Hutchins, I think his name was. The historic entrance is an old discharge point. It's equivalent to River Styx, which is now directly downslope from it, actually, by a couple hundred feet. So that's one of the upper levels, and what you have is layer upon layer, but you've got some collapse features and some other ways to get from level to level through here. Shaded topographic map of Mammoth Cave. Again, there's the Green River up here at the north, a place called Turnhole Bend right here, where there's actually another spring. It's not a main discharge, though. The visitor center will be up in that corner. The cave system is developed under here. And then to the south here, these little pimples down here, these are actually pits. These are the sinkholes that the water enters the system through. So the water enters down here, flows north, and discharges to the Green River. Now, when you go to Mammoth Cave, which I just suggested you'll do, you remember, you want to find this little town called Pig. It's not actually a town, it's more like a named crossroads. But in Pig is the Porky Pig Diner. And if you like watching the kitchen staff smoke while they prepare your food, you'll love the Porky Pig. I eat there every time I'm down there. Say hi to Calvin when you go. Okay, yet another diagram here that shows the sinkhole plain to the south is sometimes called the Pennyroyal Plateau. The sandstone capped part is called the Chester Upland. It's the Chester Sandstone. The Chester doesn't allow water to move through it. It's the sand is cemented together with clay, and water can't permeate it. So water has to come in through here and erode out. These are the names of the limestone units that the cave is developed in. And it turns out that those are the same limestone units that Carter has developed in here on the other side of the state. Blue on this map is where karst is developed in Kentucky. And, well, there's a lot of it. There's a very small karst region down here along the Pine Mountain Fault. But the bluegrass and the Pennyroyal Plateau here, sometimes it's called the Eastern Pennyroyal through here, this is all underlain by these limestones as well as karst. Mammoth Cave is out here near Bowling Green, and Carter is Carter County up here, and Carter is in there. As you drive across Kentucky, you keep an eye on the rocks exposed at the side of the road, at the side of the interstates. What you'll see is there's a lot of pits in that rock. You know, they blast half of it away to make room for the road, so you've got this half of a bowl-shaped collapse pit. Now that's because the limestone is dissolved there. You'll see a lot of red soils, and those red soils are another characteristic of karst. They're called terra rossa, which means red earth, but they develop on these limestones. Very distinctive. Okay. This is a block diagram of what's called the Eastern Pennyroyal. This is what you're dealing with in the Carter Caves area, and it really looks exactly like what you have at Mammoth. You've got your underlying limestones, you've got a cap rock, it's like the Chester Sandstone in the Mammoth region. You've got valleys where water can enter, and you develop your caves, and you have your discharges out here, and you have your base level stream that controls where the cave is being developed and what level it's being developed. So I imagine you're going to spend a little bit of time in the Carter area, so we'll take a look at the map here. And unfortunately, the map doesn't have topography on it, but let's see. Tiger Creek runs over here, on down. Cave Branch runs right here, and Smoky Valley runs right here. Now the two Three, I suppose, main areas that are commercially developed in Carter. You've got Cascade Caverns, which is actually on the other side of Tiger Creek. You've got the X Cave, Laurel Cave area. Here, you need a permit to go into Laurel, and you can only get in certain times of year unless you know the right people. And then you've got Bat Cave back here, and Bat Cave is now closed. You can only get in there if you are a researcher, and I'm thinking it's going to stay that way. I don't know if you were told about white nose syndrome.
Yeah.
So it hasn't made it this far yet, but caution is the best thing here.
Why is it called X Cave?
It's called X Cave because it's got two passages that intersect and form an X.
Okay.
They're real clever cave naming people. When you go to Mammoth, ask the ranger when you're going to see the mammoth. They love that. Now, in terms of base levels for these, I mentioned I had some students down working on the X Cave, Laurel Cave system, the valley here, and they documented that it's developed at two levels. You've got the active level with Cave Branch, and then you've got the abandoned level with Laurel Cave, and actually X Cave is at. They're up above the creek. Now, Cave Branch isn't high gradient. I mean, it's pretty close to being flat, just enough to direct the flow down to Tiger. Cascade is over here, and Cascade's base level is Tiger Creek. Again, Tiger Creek doesn't have a huge steep gradient, but Tiger flows north to the Ohio, and so if this is discharging to Tiger, these are discharging to Cave. This might be, its base level might be a little bit higher. Might only be a couple feet, but probably a little bit higher than these up here. Now, you've also got a couple ridges in here. You've got a ridge here that separates Cave Branch drainage from Smoky Valley drainage. Got another ridge down through here. And the question is, you've got karst features on both sides of the ridge. Are these features directly related to the features you see over here? In other words, could you connect them? In Mammoth, the cave is largely preserved. You've got three adjacent ridges, Mammoth Cave Ridge, Flint Ridge, and Joppa Ridge. And they've been able to connect the caves under those three ridges. So you've got, I think it's almost 400 miles of passages that have been mapped at Mammoth. In Carter, the whole thing is so dissected that the caves are pretty short. And you could say that this one's at the exact same level as that one way across the valley, and they were probably connected at some point in time, but everything's been eroded in between. So everything's very discontinuous at Carter. Caves are very short, although, they may once have been pretty well developed. And that gets me to that, but then there's the pretty stuff. We had this equation. I said that this was kind of a tenuous equilibrium here. You've got carbonic acid partially dissociates to give you your hydrogen ion and your bicarbonate ion. The hydrogen ion reacts with calcium carbonate, and you get bicarbonate and more calcium. But, if the conditions change, if, a temperature change even gets this to go the other way, and instead of dissolving calcite, you can actually precipitate calcite. One of the things that we think is so neat about caves is the cave formations. The reason that we get cave formations is because we just dissolved a whole bunch of calcite and we're free to precipitate it again. So what happens is you've got water coming through the ceiling perhaps, and incidentally you won't get this stuff in the flooded sections of the cave. This is what's going to form in a cave section after the level has dropped and you've got a flooded lower section. You've got water still coming through fractures in the ceiling though. And that water is dissolving calcite and it comes, to a big opening and it hangs there as a droplet. And that droplet hanging there, what's it doing? Well, you've got a temperature change. You've got potential evaporation and you can actually get that equilibrium shift, and before it lets go, it'll drop a molecule, or it'll deposit a molecule of calcite right there. And then here comes the next drop. They say that depending on the cave formation, and you hear people say different things, but something as big as your thumb is going to take more than 100 years to form. Unless you have really big thumbs, then it takes 200 years. So you get these cave formations here. And again, depending on how things are laid out, how fast the water's dripping, this, that, and the other thing, you'll see different things. You see these really skinny things up here. Those are soda straws. And they're called soda straws because they look like soda straws. They're hollow, very thin and narrow, and the water comes and drips through them, and as it drips through, it deposits around the edge and makes the straw longer. But over time, these will build up and ultimately become stalactites. Stalactites with the C, they hang from the ceiling. Stalagmites are on the ground, so we've got our stalagmites down here. And typically, where you've got a drip, you're forming a soda straw or stalactite. Normally you'll have a stalagmite that's at the bottom building ceilingward, and they might meet to form a column. Now, if this is going on right against a wall, rather than getting these type of features, you may just get a drapery. You know, they've got all kinds of silly names for these different features. Cave bacon is one of the coolest ones, because it looks like bacon up there on the seal. So you get all these different types of formation, just because that equilibrium shift. You dissolve the calcite as it's coming through the roof, you come into the chamber, and you can precipitate it again. You can also get some other minerals. Getting these types of minerals requires that it be very wet. If it's a drier cave, instead of getting calcite deposition, you might get gypsum deposition. And gypsum is, again, a calcium sulfate, very easily soluble. So you've got to have a pretty dry cave to get that. You've got, in Mammoth, you've got some pretty good sections with gypsum deposition. Mammoth is a much drier cave than Carter is. Although, there's a little bit of gypsum in Carter. Not nearly as much as in Mammoth, though.
I always remember being told not to touch structures like that,
Yes.
that they won't grow, or they won't continue to form for...
Yeah, basically the oils in your fingertips are going to disrupt the deposition of the calcite. Now, you could make the argument that in these commercial caves where they run, Mammoth, they have 2 million people visit Mammoth in a year, and more than 1 million of them go underground. So everybody's coming through here, and Mammoth has been a commercial cave for almost 200 years. Everybody's going through there and touching everything. We didn't really get smart about this until 30 or 40 years ago. So you could argue that all the formations in the toured parts of Mammoth are dead anyway. It's still good practice not to touch anything,
Right.
unless you're falling over and you really need to grab something. This is a sinkhole that opened up in Winter Park, Florida in early 80s, I think this was. I actually remember this being on the CBS Evening News with Dan Rather. This sinkhole opened up, you see this big lot right here?
Mm-hmm.
This was a Porsche dealership. 6 cars went into the sinkhole.
You think they would have got it when they saw the one...
They really didn't.
Think.
Well, they didn't know it was there.
Happened fast in Florida.
Yeah. Very warm climate, very high rate of dissolution. It wasn't that this huge thing was open there, but the roof weakened very, very rapidly and just dropped in. What do you do with that? Well, you fish the cars out of it, you seal it with clay, and now it's a lake. Or you make the world's largest radio observatory. This is Mount Arecibo.
I didn't realize that was a sinkhole.
Yep. Normally with a radio telescope, you turn the bowl to whatever you want to focus it on. Obviously, it's not an option here. So you've got the mechanism up here, and it's on this system of pulleys and cables, and they just draw it back and forth and focus it on whatever they want. Protection. You got a lot of water down there, and water's good. We like water. It tends to quench the thirst and keep you alive. One of the largest karst aquifers in the world is in Texas. It's the Edwards Aquifer, and runs through many counties. San Antonio and Austin both depend on it. Those are the largest cities that depend on it. Recharge zone is on the north/west side, and the what's called the bad water line is right here. This is due to pollution, and they're trying to keep that at bay. Sinkholes are convenient places to dump stuff. Again, before we got really smart, it was out of sight, out of mind. There's this big hole in the back of your property. Why not, push the old broken down car over into it and dump all your pig slop into it? And, oh, here's a refrigerator that doesn't work anymore, into the pit. And this ends up being pretty bad. There are numerous examples. There was a cheese factory in Kentucky, this is in the Mammoth region, that dumped a load of whey. Whey is really nasty, acidic stuff. Dumped it into a sinkhole, and it actually showed up in Mammoth.
Sinkhole got bigger.
There's a town up in northwest Ohio, and I always forget the name of it, but they basically did the same thing. They were drawing their water out of a sinkhole on this side of town, using a sinkhole on that side of town as a garbage dump, and next thing you know, they're drawing up toxic waste. Maybe the best example of reclamation is Horse Cave, which is near Mammoth Cave. There's a town called Horse Cave. In the middle of the town of Horse Cave is a giant sinkhole. And get down into the bottom of the sinkhole, and it opens up into this huge cavern. In the early 20th century, they used it as a dance hall. They quartered horses in it for the winter, which is how it got the name Horse Cave. And they drew their city water supply from it. Well, again, they were dumping their trash in the sinkhole on that side of town and contaminated the water supply. Ultimately, the cave had to be sealed off because the stench coming out of it was so bad. In the 90s, they got in there and they cleaned it up, and the recovery has been remarkable. So there is hope here. But again, the best thing to do is not do stupid things in the first place. So these are a really cool resource, and not just because they're neat to look at, because they do serve a purpose. They provide clean drinking water for a lot of people. So if you're in Texas, you'll see signs like this, environmentally sensitive recharge zone. That means, if you have a fuel spill or something, you get on the horn to the EPA right away. You will be liable big time if you try to hush it up and there is a contamination issue. Prison time is involved. Last thing, a couple pictures I want to show here. Old Chinese art is characterized by these fairly bizarre landscapes with these incredible rocky pinnacles. And, a little temple up here. And you're like, did they just, because they're doing this on a long scroll, just kind of compress it like this? And no, it actually, there is this kind of topography there. It's called tower karst. And these are just pinnacles of limestone. Everything's been dissolved around them. Really, really spectacular looking stuff. And again, it's what you have in Kentucky, just turned on its side. This is more similar to what you see in Eastern Europe, in a place like Croatia. All right, there's some that's not vegetated. And you see this kind of fluting on the surfaces here. It's very characteristic of the water descending. All right, and that's actually the end there. So.